Good morning. Welcome to the session on AI, artificial intelligence. I'm Mike Patterson, moderator for the session. I'm a principal and technical analyst for Totier Technologies. We're going to be taking questions at the very end after both speakers have presented. There will be a couple of polling questions up front, so you'll have to minimize Zoom and then go back into Event Mobi to answer those questions. The two speakers we have today are first Michael McShay. He's a Health Systems Innovation Lead at the Johns Hopkins Applied Physics Laboratory. And we have Jay Ostrowski, who's the CEO of Behavioral Health Innovation. He's also the CEO of Adaptive Telehealth. So let's get started. Jay, your turn.
Thanks, Mike. Happy to be here with you guys and to talk you through AI from a couple different angles. I'm also a licensed professional counselor and do clinical work. Not the full time that I used to, but I keep my fingers in it all. But I'm also part of making different tools with AI, more near-term solutions. Michael has the privilege of making bigger systems with long-term outcomes. Both of us have this strange place where there's some things we can talk about publicly and some things we can't. So we're going to try to give you as much as we can. Keep it simple for you, not to patronize, but AI can be very complicated. So we'll be sprinkling some thoughts throughout the session here. So I'm going to go ahead and put up our polling question. So if you would go to Event Mobi and click on that and give us your answer to this. This is going to be helpful to us. If you can't, for some reason, I think you can put it in the chat here, but we really prefer to have it in Event Mobi because it gives us cool graphs and stuff like that. But we kind of want to know who you guys are so that we can tailor a talk to fit what you have going on in your life and make this hopefully interesting and actionable for you. So the first one was, what's your role? Are you a clinician, a physician, a nurse, something else? Are you a technology vendor? Are you an administrator? That's kind of the first set of questions there. The second one is, do you think AI will exist in most, when do you think AI will exist in most care delivery systems? Do you think it's going to be next year, 2030? Do you think it's already there? What are your thoughts on that? So we're going to give just a few seconds more before we do that. And Mike, do you have access to that polling data yet?
I don't see it yet. I'll ask Dave.
Okay. So we're gonna forge ahead even still. And then the next one is this one I want you to put in the chat so that we have it readily accessible. Is what questions or concerns do you have about AI in healthcare? So a lot of cool things going on. And we want to talk about them today. And both of us have experience from different angles, a lot of crossover, but a lot of differences too. So it would be interesting to hear what your thoughts are as someone. And I see Kent already has a good question, and we'll definitely come back to that one specifically. I'll bring that one up later on. And then as we go throughout, feel free to put in your questions and we'll answer them more towards the end because we want to make sure we get through our slides for you and then have some color commentary at the end. And so again, I'm Jay Ostrowski with Adaptive Telehealth and Behavioral Health Innovation. My role is basically specializing in telehealth in the digital space to create healthcare technologies that are relevant and useful, evidence-based. And so I have a kind of a clinical hat in consulting, and then I run a company that makes the software. So to kind of take it from both of these, and we do have a few AI projects in the pipeline right now that are they're well on their way and some experience with that. So I'll be sharing some of that. Again, some of this stuff is proprietary. We can't share too much, but we'll definitely give you a lot of good stuff here. So the first thing I wanted to point out, I think this is probably the most relevant. As we look at AI itself, it's important to recognize that AI is not just a cool thing, it's actually solving a problem. And telehealth can only go so far to solve this problem. The problem is this, we have a serious shortage of mental health providers in the US. And as I work with clients in Dubai and in Singapore and Thailand, all over the world, they have the exact same problem. In fact, they look to the US and the UK to pillage our providers and have them work in their settings. So that's the number one fact that's definitely a problem. The second thing is not a problem, but it's kind of a cool thing, is that there's a growing awareness and data sets out there, evidence that mental health care is essential to physical health care. So if you are depressed, you're not going to be exercising, you're not going to be social, you're not going to be taking care of your life in a way that produces health outcomes. And you're probably not going to be compliant with your medication, or as compliant as you should be. You're not going to be eating healthy or thinking about those things. All these things kind of weigh on the physical health and add costs to our system. Setting aside even, psychosis and suicide, there's quite a lot of us that are affected. Our physical health is affected by our mental health. And then the third thing that I think ties these together in a different way is the pace of training of new providers is far outpaced by our population growth. So I forgot what the numbers are, but we produce kids like by the second here in the world. We're not producing providers at the same rate as we are producing children. So we already have a crisis now, a shortage of mental health providers, and that's expected to get much, much worse as all these facts tend to grow. So I have two conclusions that kind of frame why we're doing AI, why are we in this space. And the reasons I'm in it is we will never have enough mental health providers. We'll never have enough to meet the mental health needs, behavioral health needs of the world. So given that we'll never have enough, we must create new paradigms and new scalable solutions and resources for both detecting and treating mental health issues. And some of that is actually the treatment of them and even self-help kind of things that don't involve humans. Now, I'm as a clinician, I don't think that we're ever going to get rid of clinicians. These are more, the ways to think about this are tools that will help clinicians or help us research, help us diagnose, help us prevent, predict, and then treat, and then have self-help as well. So lots of different ways we can approach this problem with AI, and we're going to talk about those a little bit more in detail. So what if, right? What if we could do things? This is the blue sky thing. Start thinking about what would we love to do with technology? What could we do with this? And there's quite a few things. So think about this. What if we could take an Uber model or an Amazon model for mental health that we take for products, right? What if we could have mental health show up at the person's doorstep on demand or on their computer, on their iPad, and it really helped them in a very meaningful way, and in such a way even that it reduces some of their symptoms and even is preventative of new symptoms as they arise, new conditions. So what if we could use AI to kind of evaluate the clinical care? So using video, we're actually, we don't do this normally unless we're in training, but we could be recording our sessions and advising the client we could be recording our sessions and we could be advising the clinician on better treatment methods to kind of audit them. So that's a very real thing that we could do with AI. If we get a large enough data set, we could start optimizing some of how we go about treating, and we can coach and train clinicians to be better providers, to use more evidence-based treatments. As a provider, I'm also an educator. I teach a lot of classes on telebehavioral health. I've taught on, psychopath and on metaphors and on different treatment paradigms, personality theory. But I would say that, every clinician is so different in how we approach things. Even though we might say I'm cognitive behavioral or I'm this or that paradigm, how we implement those are different. And what if we could use the masters that do it well to coach those that don't, using machine learning and AI? So we could even improve our workforce to be more effective. But also, what if we could just start screening and finding people earlier in there? So I'm not going to go too deep into the what ifs, but here's a really poignant what if. Like, so this is a real example of something that's been done, and this article is from last December, okay, a couple months ago. This was published about Facebook. They're using, they did a trial of data with about, I think it was 223 participants, where they looked at their Facebook posts over a couple year period. And from that couple year period, they were able to predict using AI who would eventually have a mental health diagnosis. Imagine that. They used Facebook data, and they scanned all this Facebook data, and they were able to predict with a fairly high certainty. I think it was in the slight high 70s% of who would have a psychiatric diagnosis a year from. So this is like schizophrenia, psychosis, major depression, suicidal ideation. Right now, Facebook actually, when they screen and find words that correlate with suicide intention or ideation, they actually post little things, little resources for people. And Google, I've noticed, has also started to do that. So when I do some research on suicide or something like that, it posts to me because it's thinking that maybe I'm struggling. Now that's to me kind of a good use of AI, is like just-in-time tools for and links and resources to people that really could need that at the time. But this also kind of has this other sense to me of, ooh, is this like Minority Report? If you remember Minority Report with Tom Cruise, where they were going to intervene in crimes before they happened, and they go and storm the place, and they may kill somebody, or they may arrest somebody before the crime happened. Now, with all this data out there from Facebook and LinkedIn and all these other platforms, Google and Facebook and Amazon, they already have profiles on us. And they already know maybe more about us than our spouses and kids do. So there is this kind of creepy privacy ethics issue that hasn't really been addressed adequately. And this other part of this other tension of, we could use this for a lot of good in a lot of ways. So up front, I think it's good to kind of put out there that while these tools have a lot of use and are being really kind of cutting edge of treatment focused and helpful, they also have some kind of parts that make me squeamish as a clinician. The ethics part of me is like, ooh, should we even be doing this? And could this prevent somebody from getting a job in the future, or getting insurance in the future? This is not HIPAA data because it's not associated with healthcare providers in this space. This could be used against certain people and discriminate. And that's one of the worries that I have. So I'm looking at, can we make ethical, tools and legal tools that are really kind of, helpful, knowing at the same time that there's probably going to be some misuse along the way. But hopefully we can, find a way to shine the light on the ones that are working well and use those in a good way. Bad actors are always going to be there, as we all know. So while it might seem some of this is far out, some of this is happening right now in trials. And I think, both Michael and myself, we're part of companies that are actively making these things as we go. And we'll talk more about some of those issues. Now, this is another example of AI being used right now. This is, I believe, an IBM trial, a Microsoft trial, where they are actually using it to stratify patients into subtypes to respond and find out which ones respond to better treatments. So they're stratifying different types of depression and different types of anxiety, and then looking at treatments and finding out which treatments have better outcomes. That seems like a pretty good research-based and good use of it. Predicting client engagement. So what we know is about apps, if you make a great app, there's this fallout rate very quickly on many apps. And so getting people to engage in the app long enough to get the treatment that would help them, just like in counseling, some people come kind of pumped up and ready to work. And then there's kind of this lull at some point where they lose energy, and you have to kind of keep them engaged in therapy itself. Same thing with apps, is that in my experience, an app on its own does not have long-term positive outcomes. It's usually when an app paired with a provider that gets a longer term and better outcomes. Definitely in some of the ones that I've done. The other one is intervention. So they're using it to intervene earlier. So this is kind of a triage system where the computer is able to, the software is able to engage the client earlier to help themselves before they even get to a provider. So you can obviously read the screen for more of those, but we're able to, do quite a few types of things. And this is just an example of real world applications that are in a lot of beta right now. Um, the earliest one you might be familiar with was ELIZA. ELIZA was built in an MIT lab, as a lot of things are. And this is the very, look at the size of that box and the font on the screen, right? That dates us. Remember when everything was like that? I do that. Those were in dial-up days. So that was ELIZA. ELIZA was a real-time chatbot kind of responding with machine learning back to the user. And it was actually pretty good to a point. So initially AI is pretty good at the kind of the initial chit chat conversational flow. It's just when it gets into the clinical areas where it gets a little bit more difficult. It's better on the treatment approach, but not as good in my experience so far. I want to say so far on the diagnostics part or the exploration of the client's issues. But that's kind of another story. Another kind of example is just chatbots in general. And this is what I'm trying to do here is, as you might see already, is we're not trying to promote any one vendor, because we know there are lots of vendors out there and there are lots of apps out there. We're not promoting anybody's business. So, but I want to show you some good use cases. This is one where a chatbot used with university students with depression. They showed a reduction of 20% of PHQ-9 scores over 2 weeks. Some people might, I could pick at the study itself and say, well, who's leading the study and things like that. But I think it does show that there's actually some effect that you can have. And I think as we get better at this and more research down, we're going to find that more and more chatbots are engaging people at a level that is meaningful. It's also surprising when we think that, you might go, well, I use chatbots now, and I hate, like when I'm chatting with the airline or I'm chatting with the some company, and it's a pain, and you're like representative, trying to get the keyword to get them to get a live person on the line. However, there's something pretty interesting here. There are some studies that are showing that people are really engaged with these chatbots. There's also something called the disinhibition effect that's been around for quite a long time. What we find with the disinhibition effect is that people are, and this is proven, that people are more willing to disclose very sensitive information about themselves online. There's something about, eyeball to eyeball that it makes us a little bit intimidated. So we find that the screen itself opens up people a little bit more. So even telehealth has this ability to allow people to be a little bit more vulnerable than they would be in person. This is like on average, it's not everybody, of course, but there are large groups and good size effects of this. So the disinhibition effect could help us get to the root of an issue a lot faster. So imagine using that as a tool along with therapy to kind of forward therapy process a little bit faster than you would on its own. Another one, another use case, think about this, is passive continuous monitoring. I'm wearing a smartwatch now and working with some smartwatch vendors on, what can we do with this biological data, right? When your heart rate goes up, when your temperature goes up, when you're sedentary, your body is not active, but your heart rate's going through the roof. That could be a sign of some emotional something going on, or you're sweating when you're not supposed to be sweating. There's a lot of that can be done there. Or imagine your clinician looking more at your whole health, saying, hey, it looks like you're not sleeping well, or you're up a lot in the middle of the night, or you're not getting much activity, and having the data to inform care would be so powerful. So all these apps and devices have some limitations. So I want to acknowledge that up front. However, as we start tweaking them and working on them, there's more and more use cases are growing of how we can apply these. So I think as I see it, AI is in its infancy in a way. I think in 10 years, I'm going to look back at this webinar and laugh at what we present because we're going to be so far advanced. The knowledge and technology and capabilities are just by leaps and bounds every year. So I think as we look at the data right now, the big part of the problem is the data, and I'll come back to that. But some of it is usability of the apps and getting compliance with the apps along the way. So in my view, the most efficacious right now is AI plus clinician. And there's some use cases here where there's a clinician, there's AI, a chatbot 24/7 that can escalate to a clinician along the way. Also, avatars are quite effective. This is a Ellie that was designed originally for veterans, and it's kind of an engaging simulation that they found pretty effective as well. And this is one where they're actually using an avatar to work with psychosis. And I just want to play it, see if I can play it here a second.
You ready, Owen? Good stuff. You're worthless. You're a waste of space.
So what's happening here is what you saw as a psychiatrist has worked with this client to modulate the voices in his head. He's schizophrenic, and he has these voices going in his head. So the clinician worked with him to kind of try to make the voice tone and the cadence similar to the one in his head. And now they're going through kind of live therapy to have that person combat this or respond back to this in addition to medication treatment.
Oh, and I want you to talk back to the avatar as strongly as you can.
Stop it.
You're worthless. You're a waste of space. Your life's going nowhere.
Stop saying those things.
You're nothing.
Leave me.
So they have found pretty good outcomes with that work. So it's kind of exciting. So I'm going to go on to our next slide to. So there are lots of different types of machine learning, and I think Mike's going to get a little bit into this as well. But there's lots of different types, and each of the types have kind of different challenges. But the big picture view I wanted you to get is that there's a lot of progress being made, and you're already actually using some of this AI in Amazon. You're using it in Facebook. You're using it in Google. It's already behind the scenes, and we're just taking these same tools and we're applying them to mental health. There's also billions of dollars being funded. I've fuzzed out the names, but these are all big projects. This is from 2019, so they're actually bigger and bigger amounts every year pouring into artificial intelligence. So there's a lot of different types of uses. So prediction, prevention, if you look on the left side, detection, response to treatment, maintaining good mental behavioral health, and then of course relapse prevention. And then for the provider side, we can do it for epidemiology studies, monitoring and alerting for high-risk patients, even low-risk patients, making better evidence-based treatment plans and recommendations, and just tools to facilitate training. And then I think we need to be working more on provider resilience as well. So AI right now is in a lot of different places, and I think we need to recognize that it'll be growing. The lower tech that we have right now is more of the kind of self-check-in and the kind of triage systems that can be used with that as well. But what we find is the bigger problem is that adoption in mental health in general has been kind of slow. And we're hoping that that'll change very soon. A lot of it is, I think, the clinicians are not in a space where they've been ready or primed for this. So we have some people that are technology ignorant or technophobic, and that are the providers or the leaders in this space. We also, as a group of clinicians, don't always like change. It might feel threatening instead of feel like an adjunct tool. So we need to be framing it and helping them think of it more as a tool to supplement and help with treatment rather than something that's going to take their job. Also, the bar of acceptance should not be perfection. it should be usefulness, helpfulness. So AI is not going to be perfect, nor are clinicians, right? So if you have, we find even with the DSM-5, there's not a 100% consensus on diagnosis or diagnostic criteria or the presenting picture on the entire spectrum. So I think there's some grace to be done there. So I think it's, again, like telehealth. People would say, well, is it as good as in person? And I would say no. I as a clinician prefer in person. I would say, is telehealth better than no treatment? Yeah, it is a lot, arguably by quite a lot. I think the same with AI. Is AI going to be as good as in person? Probably not in the near term, but it will be a useful tool for many people, and we should look at it that way, as a useful tool. Another challenge that we have, though, is we need a lot of data. We need a lot of data to do this, and we don't have that data. A lot of it's locked into thousands of different databases with different database structures. The data may not be clean and may be skewed in several different ways, just like Facebook data was very skewed in different ways. I mean, people, anyway, I won't go off on that tangent. We have a lot of handwritten notes too, and that makes it near impossible to get that data. And then we have the paradigm of clinicians. We've been taught over and over again that the research shows, and it does show this, that the relationship is the highest predictor of positive treatment outcomes. So with that kind of backdrop, it's hard for us as clinicians to recognize that all these things could be useful tools. I do point out often to clinicians that when the self-help craze kind of went through a couple of decades ago, there was kind of this fear that it's going to replace clinicians. And I think we found over time that they have helped a lot of people and maybe kept some people, I think, appropriately out of treatment. But more than that, they've been a very useful use case for helping clients and useful tools that clinicians use as part of their treatment protocols. I think AI will take the same path of the self-help tools in the near future. I'm going to zip through what is AI because of time. And I know Mike's going to talk about this somewhat, but I'm just going to make a couple notes for you here. So as you think about what is AI, it really is computer algorithms. So we can do this in 3 separate buckets, and this can be reconfigured in different ways. But how do we sense and monitor with computer vision or text collection or audio collection? We're able to, for instance, determine stress levels through people's voice modulation. And we can recognize a lot through patterns of text and then how they look visually. So all that, the computer could take that composite and do something meaningful with it. So we're collecting data in one part. The second part is we're using the computer algorithms to understand what the data is, what it means, right? So how do we pair that with models of information that say, here's what the data is, and then here's what it means. The third part is acting on it. So what do we do once we know what it means? How do we use the computers to interpret this and act upon it? So there's lots of work in each one of these phases that could be done. And these are lots of core areas. I've already talked about many of them already, but just sensing the Internet of Things, gathering data from your environment to help paint a better clinical, a more holistic clinical picture. Triage, helping people get quickly to the appropriate type of treatment. So that means screening and collecting data and leading to the right places. So there's a lot. Explainable AI is even one that I kind of like. That's what we're doing right now. We're kind of helping you understand how AI works and deconstruct some of the myths. And some people have kind of this magical idea about AI, and some people have a very cynical idea about AI. I'm kind of more in the middle of kind of practical researcher, developer type. And then, there are lots of different processes, and this is a very crude way, but of thinking about development. But we basically capture the data. We have to cleanse the raw data because the data itself needs cleaning and categorizing and labeling. And then we use machine learning model. We have to create the models and use the models on the data. And then we're using it to train the model of the AI, and we have to retrain it until we get it right. And we go and change our data, we change our model, and then we retrain and get better and better outcomes, test it over time. So again, there are some limitations, garbage in, garbage out, right? That's the same with, that's actually not that different from real life clinicians. If you have poorly trained clinicians or clinicians that are having a really bad day or are sick or checked out because of something else, they're not going to do clinical work, right? So that same kind of garbage in the human sense, or if they're poorly trained, right, or they don't really know how to treat a certain person, that's the same kind of limitation you have with AI. Also, clinical validation. This is we need a lot of data, but then we need to validate that parallels or is useful clinically in real life situations. And then I think the two biggest ones are the perception and adoption. And again, these are all problems I think we will solve over time, and some of them in the real near term. But we do need to be talking about how is this perceived, how is it rolled out, and really involve clinicians in the development and advisement of these so that they can habituate to the idea of using these tools over time. So thank you, and I'm going to push it over to Mike.
Thanks, Jay. I do believe that mental health is a really exciting space for application of this technology. Let me get this started. All right, so Mike already introduced me and my role a little bit. I did want to point out that everybody knows Johns Hopkins when they hear that. I'm actually at the Applied Physics Lab, which is a part of Johns Hopkins that is a university affiliated research center. We do all kinds of work with Johns Hopkins Medicine because I'm in the National Health Mission area of APL. But we also do a lot of work with military health systems and military medicine. And so that's informing part of my, my talk today. And I'm going to focus more broadly on the role of AI and what I'm referring to here as next generation telehealth, and really kind of point out in a couple key ways that I think it's already here in effect. I do want to say up front for everyone's benefit here, and much the way that Jay described his view, practical view of this technology. I am not a data scientist. I do not build machine learning algorithms. I do lead projects that build those kinds of algorithms in the past, and I've done that as a product executive as well in my past. And I do want to say upfront that I am a recovering product manager. So now in the research world, and one of my roles at APL is to know where the edge of innovation is out there. And so that's informing a lot of what I'm talking about here. So let's jump in. So yeah, I do have my very own theory of the universe up front too, in terms of how AI in a wide variety of ways is going to start driving connected health. So I'll talk a little bit about that, and then give you, this is just world according to me, 4 AI trends I think that are defining next generation telehealth. And then I'll wrap up as well with some challenges. I do want to leave time for questions. There's some great questions in the chat. And may answer a few of them as we get going here. But I'll start with the universe. I think we've all been very sensitized to global health security. Most of us operate at the population and individual level, probably on this call. And thanks, Mike, for posting in the chat the composition of the group from the poll earlier. This is kind of the canvas, from our perspective in the National Health Mission area at APL, of the different domains where innovation is really a huge opportunity in healthcare. And we won't spend a lot of time at the global health level today, but we do tend to look at things in terms of the life cycle of care. And so we have this term that you may have heard if you're anywhere close to the military called the left of the boom. I didn't actually learn that term until I went to APL. Left of the boom means, when you're in national defense, it means literally before the explosion, before the kinetic activity, if you will. In healthcare, it means before the injury or sickness. And so, a lot of our focus is on that side of the equation, predicting, preventing, detecting changes in health. And then assured care is more on the delivery side. I'm going to focus, though, on what I think are the 2 most driving trends that will affect population and precision health and then connected health. And the first is the convergence of population and precision health. And by that I mean in population health world, we're all about, risk stratification. I think many view, and I'll include myself as one of them, view telehealth as a population health technology. But more and more data means you're able to get more and more precise about smaller and smaller populations within that population health data set. And so I think we really see that convergence happening, and I've been involved in some research projects with the Center for Population Health IT at Hopkins, Bloomberg, around that. The next trend is from reactive to proactive. And I think that both of these trends are very much driven by analytics. And so in this very, very busy slide, I want to just kind of throw out the point of view that, and I'm still a believer that payment reform and value-based care is a driver in healthcare. It's not happening nearly fast enough, but as we are caring for populations with those kind of payment models driving behavior, there is definitely an increased use of machine learning and better analytics, better use of data for prediction. And there's more data, whether it's social determinants or wearables. And what's happening then is, as the techniques for analyzing that data and machine learning techniques that Jay laid out in his talk are getting better and better, and the tools are getting better and better, these population health programs are able to predict with better and better precision, not just those that are in bad health and need care managers and that sort of thing, but those that are trending towards bad health. And I think the challenge in population health is you can't keep hiring nurses to manage these patients that are at risk. As the numbers get bigger and bigger and your ability to predict it gets sooner and sooner in the process. That really is the opening for connected health solutions. And whether you use the term telehealth, connected health, digital health, for the sake of this discussion, it's all the same. I think that even when you can provide in-person care, that is limited to what happens during the interaction with the patient. Connected health really stands to change care delivery pretty dramatically, I think, once we have a better idea of who is trending towards bad health. And once we can really engage them, sometimes with a clinician on the other side and sometimes not. So this is how I see all these things coming together. I will mention that the picture here happens to be in our health engineering and analytics lab at APL in Laurel, Maryland. We were simulating a pandemic in the Washington, DC area in 2018. That's the picture on the screen there, just coincidentally. So I'm going to start with a bit of a baseline before I talk about trends. And I will tell you my background is in telehealth. From the early days, I've been in healthcare more than 15 years, and started really with a little company called VisiQ, which later got acquired by Philips. But I think that one of the first things I learned when I got into healthcare and into telehealth is that it's not all about the video, right? And so what's interesting about that is, for this telecritical care solution in particular to be highly successful, it's really three essential components, three legs of the stool. And certainly the interaction and communications with the bedside care team and with the patient are important. But clinical decision support is a huge driver in the success of the ability to manage lots of patients through this kind of system. How does the clinician, the intensivist, know which of the 150 patients they're looking at needs attention right now? And really, that is AI. That is a form of autonomous monitoring of the patients, reducing the cognitive load on the clinician in order to point to which patients need their attention at a given point in time. And the other real critical thing here that we've all learned, probably the hard way, I'm sure there's more battle scars on this than I have out there in the audience today. You can't introduce these technologies without actually transforming the clinical workflow to accommodate these technologies. So that's a baseline from my perspective. AI is already in telehealth. I like the first answer we got to our question of when will AI be in healthcare as being right now from some folks. But there's also some lessons here that I think are important as we head into an era and probably a decade or so of rapid growth of the use of this technology. There's really three important lessons I wanted to just kind of point out. One is operationalizing the analytics and creating an operating environment that is driven by the data to the extent that there is zero tolerance for bad data input has to be a goal from the beginning, because it has kind of a virtuous cycle to it. It improves charting quality and data quality if the clinicians are starting to live by these alerts. The second thing I learned is it's hard. At Philips, we created the EIC Research Institute. We had more than 6 million patients of data to mine to develop algorithms. And it still took quite a few years to bring one of those algorithms to market. And lastly, the battle is not won when you have, an incredible, highly predictive and highly accurate alert that you can bring to a clinician. The battle is won when the clinician can actually use that information and take action on it. So that's just a little baseline setting. I'm going to transition now to 4 trends that I think are really interesting, in how AI is finding its way into telehealth solutions. I will say right up front here, this is not an endorsement of any of the companies I'm highlighting. However, I do think there is some interesting trend lines that are worth pointing out. And I also would point out that while I have contacts and engage many of the companies I'm going to talk about, some I don't. So if you're in those companies, please reach out to me. I'd love to hear more of an inside story. But I think there's enough out there in public, I think, to really point to some interesting trends. So let's get into that next. The first is intelligent sensors. And I swear I picked TytoCare for this slide before I knew they were a lead sponsor for the event. But I think, there's other solutions out there as well that are really interesting. The real question is, with all this new data out there, whether it's EEG signals from Emotive, using AI to help consumer administer the device, or in the case of ADAR, which just got FDA approval, they actually have breath analyzers. There's a whole lot more data that's going to be entering into our remote and virtual care. The second trend is video as a diagnostic tool and even therapy. And here's a few interesting companies that I'm tracking. Dermatology is a really interesting area. I've been fascinated myself, and I know Philips is doing a lot of research in using video data to actually detect vital signs. Imagine being able to grab vital signs from a video interaction without having to have medical devices on the consumer side. Neura is an app you can download now and try that uses a picture of your face for blood pressure. And virtual reality is starting to come into the therapeutic domain. So I really think that how we use video is going to be radically changed. AI is often a front end for telehealth services. And I think that is a trend that actually started in the contact center world. And we've all maybe experienced chatbots, that try to interact with us before we get transferred to an agent. Think of it that way. And there's some really interesting companies out there that are getting better and better at it. GPT-3 is certainly, as a technology for voice and natural language, is really impressive and capable. Jay already mentioned Wobot. I think Ask Sophia is another really interesting example with great technology underneath it by a company called Next IT that was acquired by Verint. It's really interesting to see these things pop up and get better and better. And so the idea is, even in care management for population health, if you can do some more mundane interaction with the patient before the patient gets transitioned to a clinician, it's really efficient use of clinical capabilities and capacity. Ambient AI is the last trend to highlight here. And, there's some really interesting stuff happening out there. Vital Chat I mentioned here because it's the first company that I've found, at least, that is doing computer vision based edge computing and AI with the video, with a really interesting set of applications. Saycara is, I chose this very explicitly because it actually helps clinician with documentation. SugarPod is an interesting application by Wellpepper that is more consumer-based for diabetic care, and Sincera similarly for aging in place. Sleepy's even using radar to detect sleep apnea. So I think more and more we're going to see more sensors that are ambient and just part of our environment. The net of all this, though, is lots more data and lots more AI. So next couple slides, just to throw the cold water on, because that is kind of I think in vogue a little bit. I think that anyone that's tried to use this technology realizes it's hard. I would recommend to anybody in the audience to read Eric Topol's book. It's about 3 years old now, but it's still very, very prescient, I think. And he points out that the load on clinicians, the time with patients, their own cognitive biases make it a ripe environment for algorithms, but the current applications are still pretty narrow. So, I think that the question is, how can we use these algorithms to make doctors better? Certainly not replace them. And I think there's at least some concern out in the AI community, that we may be in for another AI winter if we don't figure out how to bubble wrap this technology and make it safe. And more kind of bad news, consumers already think you have these capabilities. 86% of them, would like to see more predictive capabilities in their digital health tools. This data is from the Digital Health Collaborative, which is a really interesting cross-industry consortium that does research. It's in its 6th year of research with consumers, and not on this question, but on others. It really became apparent that they think that if you have their data, you're already implementing AI to help their health. So just to kind of give a bigger picture view before we transition to questions in just a couple of minutes here, I think that APL is one of many organizations out there that are really driving research in AI. And if you think about Eric Topol's conclusion, machines recognizing patterns, that's basically where we are at the very kernel of this slide. And by the way, near term from our perspective is 0 to 3 years, midterm is 3 to 10 years, and far term is 10 to infinity, right? And I think that, human-like intelligence is expected in something on the order of 25 years. And I think that the way we organize our research is around vectors of improving AI. And these map pretty well to what Jay showed before: autonomous perception, decision-making together, creating opportunities for closed-loop autonomous medical devices and things of that sort, machine-human teaming, bringing in robotics. And the last leg here, really important, safe and assured operation. I noticed some good questions, that we'll get to, I hope, around how do you make sure it's safe? What are the liability concerns, that sort of thing. There's actually a whole science around this that is very immature, but starting to mature. And so just to end on it, what is trustworthy AI? As I said, there's not an accepted definition, but I found a very interesting and a very good definition in Executive Order 13960, which is really directing federal agencies to invest in trustworthy AI. These are some good things to think about. Does the AI respect your values and have human goals in mind? Is it performance driven, or is it noise? Being accurate, reliable, and effective is all about making sure things like biases are not introduced, or at least noted, understood, making sure it's transparent, monitoring it, making sure it doesn't drift from its accuracy. So these are very good concepts. We have the Institute of Assured Autonomy, which is a joint effort between APL and the Johns Hopkins Whiting School of Engineering that is looking at a lot of these issues. And finally, what's the to-do list? Well, hopefully from Jay's talk and mine, you get the idea that this is coming. It's already here, in fact, in many cases, and we have a lot of work to do to get good at it. I think just if I could leave it with that thought, prepare for more data, prepare for understanding how to fuse that data together. I think that Jay's slide, kind of showing the development process, points to a whole field of technology and IT development called ML Ops. So if you just figured out DevOps, guess what? You got more to figure out. But there's also some really important things, I think, to track and to a mindset to keep. The mindset is, think of it as a systems engineering problem. AI is a great technology. You have to engineer it into the system, though, for it to be effective. And so I'd encourage you to take that view of it. Follow closely what the FDA is doing with their SAMD action plan, because they've actually codified some of the best practices that are needed for these algorithms. So whether you're a vendor building one or you're a health system building your own, rolling your own, these are good practices to follow. And then even though there's not an accepted definition of trusted AI, I would encourage you to come up with one for your organization. And with that, Mike, back to you to moderate some questions.
Excellent. Thank you, Michael. Thank you, Jay. So now we're going to open it up for questions. And we have a lot of folks on this call. So I'm going to ask that you unmute your microphone, ask your question, and then mute immediately after that so we don't have any bleed over of audio. So who's first?
May I ask a question or point out a bias that I saw in your material?
Sure.
My name is Victoria Moy with Innovatio Health Design, and we're actually involved, we're a startup involved in predictive analytics to be used in home settings in the advanced illness sphere. So the bias that jumped out at me was the avatar, a Black man as a bad guy. That really jumped out at me. I think there's no need for that at all.
Well, I would say that's not our video.
Right. No, I understand.
Right.
Yeah.
So I don't want to argue with you about it, but it was just a representation of what that scientist gave to us to do. So I don't think it represents a bad guy. That was the client's version of that voice in their head. So we're not representing any racial bias or any, anything like that. This is not, and that's not what we intend to do. In fact, there was a question, if I could just pivot to the question about racial bias, because there's it's a good observation, but I just want to point out that that's not where we're coming from. And we do want to be sensitive to that because it's a very important issue right now, especially as a white guy talking to you. One of the biases in the data that Michael and I see quite a lot is that a lot of the data was built with white middle-aged guys, which I'm there. And as I work with people in the Middle East, and they're of many different colors and different languages, we have white American data that people are trying to force on these other populations, and it just doesn't work. It creates biases. So what we really need is diverse data from all cultures and all walks of life, all colors, all languages, to inform us, to inform the AI. And there's a danger that we use basically very narrow data sets and representations and misapply them to other clinical situations. So for that reason, I usually say, because of the limitations of our data and our models, we really need to be looking at using these tools as guides and kind of an awareness of where to poke for things, but not as an authoritative anything. So I appreciate you brought that up, and I'm glad, because I want to clarify that that's not our position at all. And then also answer the question that we need better data. So one other thing I would say, someone mentioned, what are the institutional kind of barriers? I would say, as large institutions, if you could help us collect good data, that would really escalate the development of AI. But again, you need to put it in the hands of good people that are going to do good things with it. So I'll step back and allow Mike to lead from here.
Yeah, I think you've answered it really well, Jay. And I think that anymore, at the outset of any project to develop algorithms, understanding the inherent biases in the data is a design step. Characterizing that and understanding the limitations of what you're developing, or fixing it by getting a better data set and that sort of thing. I also just wanted to point out that that's not just a design problem at the beginning. Because the population can change and the accuracy of what you built could drift, if there's biases that go away or new ones that enter into the situation. So it's really important to be diligent and understand the limitations of what you're building.
And I would say that's part of the issue, is keeping your eye on who is this made for. As a counseling psychologist, I've been a lot involved in creating tests and assessments. And I cringe when I see people misapplying the assessments because it wasn't developed with that population in mind or tested on that population. So we can't extrapolate the outcomes and the usefulness in tests. Same thing with AI. We can't just apply it to everything and think it's going to be equally the same.
Thank you. I appreciate both of your, your assessments of this. It's something that we're all struggling with, and because there's limited data, as you say, and we have to be very careful with the biases.
Right.
Thank you both.
Good point.
Okay, who's next? Don't be shy.
Hi, this is Rebecca. I have a question, and thanks so much for the great talk. You talked about changes in healthcare, and there will certainly be changes for our workforce, right? That was from yesterday's lecture. What about the skill sets needed for the changing workforce, and where to get these skills?
It's a really narrow question, Rebecca. Thank you for that. I think, to be honest, we're just now seeing the weaving of telehealth education into our educational systems. So I think probably continuing ed with people kind of working on the cutting edge is probably the place to start. The biggest barrier to me is seeing that clinicians are just kind of unaware of the options, and we need to be educating them and habituating them to the use of technology as a tool, and then be aware of the biases and the use cases, and then how to weave apps and technology into the care system. I think it's an emerging part of our education system.
Thank you. And for those who have already moved ahead and are already trying to get that technology training, where to get more?
I actually message me and I can give you some resources. I don't have them on the top of my head, but I would happy to help you have you find them. And you can
Thanks, and
actually
will do.
contact me through matrc.org. I'm one of the consultants, and Mike's Patterson's one of the consultants there. You can just select me as one of the people. If you want to ask me a question, I'm happy to help you.
Thanks,
I
will
don't have a
do.
lot to add to that, but I often get asked, what should my kids take in college, right? If they want to go to med school eventually. And the answer is I always give is anything to understand data and understand a little bit more about how these algorithms are built, so you know how to use them. But that's clearly not there yet in the education system. Having had a niece that just graduated from University of Maryland, I know there's still very little of it there.
Thank you both so much. Working on it.
Good questions. So if folks are shy, we can answer the ones in the chat too, Mike.
So actually, I have a question for Jay. that. So one thing that I've been watching very closely that's very interesting in mental health applications of digital health, and this actually does point to one of the questions that was in the chat earlier, is this notion of digital biomarkers or phenotyping using digital data. And I think there's some really incredible work being done and some actual real applications out there today that are using this kind of technology. Anything from your keyboard strokes as being an indicator of potential mental health issues, as opposed to how you use your phone, whether you're on social media, interacting with people, accelerometer. There's so many sensors in the phone, right? So I'd love to hear your thoughts on what we might expect to see over time around that technology. And the question in the chat was, a little bit about the ethics of this, and more pointing to, I think, the Facebook example you used, kind of noting that social media itself can be a challenge for mental health, and now it's measuring your mental health at the same time. There's an interesting dichotomy there that someone pointed out in the chat.
Yeah, so I could pick at those studies. That's what I was trained to do, is to be very critical, to not just bite whatever's going by and swallow the wrong stuff. So I could pick at the studies, but then when you step back and look at just a huge volume of data, that's the key to this, is having that huge volume of data. They're able to make really strong predictions from lots of tiny bits of data that we're not even aware that we're giving them. Like when you get on your phone, when you don't get on your phone, what you pay attention to, don't pay attention to. They're using every bit of that data as part of these algorithms. But yeah, if you wonder if you've given Facebook permission to use that, you probably have. Have you read the terms and conditions of Facebook and how every time they update it, we just go, yeah, accept. They probably own your house by now, and we didn't even know that we gave them permission to have everything that we own at some point. Same with Google and Amazon. They're collecting and using this data in kind of creative ways. So I would say one positive part, Mike, is I know as a mental health clinician, we're told to use biological data, but we're not usually trained how to use the biological data as in the mental health counseling field, more in the medical side of things. So I think this is kind of a new frontier where we have pretty good data. We can debate how good a data it is, but it is some data versus no data. And I think learning, as you mentioned, how to interpret that data and how to use that data, it is kind of supplemental to what the clinician's seeing in a little bit of time. But like for instance, if my client is saying that they've had a rough week, or they've had a great week and it's just been today it's bad, if we could look at their biological data and maybe even mood check in and say, you did great on this day. What was going on that everything was so great? Or you did really, it looks like a rough Thursday. What was happening there? Helping them remember their daily tasks or what is it that triggers them is a huge part of that. And looking at their whole lifestyle, we know that lifestyle is part of our mental health care. So I think this data will help inform a lot of that better and better as we create algorithms and tools to serve that up easily and quickly to a clinician and categorize that into those phenotypes and structures that are useful and meaningful quickly. Because as a clinician, you don't have a lot of time to look or assess the data. So we need some of the AI to think for us to get us to actionable items. But I think we'll have a lot more of that in the next couple of years.
So you just heard another thought, and Mike Patterson, if it's okay, I wanted to jump to the question on liability, if that's all right, real quick.
Absolutely.
So yeah, really good questions. A few of them around, well, who's responsible? If there's this interleaving between whether the human is in charge or the algorithm in charge, right? I think it does speak to the issue of all this data is out there. How are you using it? I think that back in the day, at least, we used to refer to failure to detect and failure to rescue, right, are real issues in hospital environments, for example, in ICUs. I think there is a whole field of study around the liability question, and it's a human-machine integration type question in terms of who is in control and how much control was given by the human to the machine. But I would say that nowadays, at least what's deployed out there is very much to inform a clinician to make a decision and rarely to make a decision on the patient's behalf outright. But that's going to change over time. And so these questions will become more and more important as that happens. But I think the other question I would like everyone to have on their mind is, now that, high tech and era has digitized all of our health data, and there's something north of 90% adoption of EHRs, what is our obligation to use that data if we can prevent harms to patients? And I think that at least I would like to see a shift in the thinking of the data is there and we're not using it as effectively as we could to help patients and save patients from harms and things like that.
So I think the liability issue is a very good one, and I've worked with several clients that we're making an app and their lawyer will say we're not going to collect that data because we don't have a good system of using it. And I've worked with others that are saying let's collect it and then let's create a good way to use it. So it depends on kind of the defensive posture of your organization. But I would say the parallel I would think of is recording video. So some people would say, I don't want to do telehealth because they can record my video. And I would come back and say that ship sailed about 20 years ago with the invention of smartphones, because every client's bringing a recorder into your session already. And so I don't think it's much different than that. And they can record your screen without you knowing. So part of that should be part of your process and consent process of how you work with clients to educate them on what's appropriate and not appropriate. But also, if you're doing good practice and you're showing that you are doing good practice, you're showing that you're being proactive about what you do with your data. Those are the companies that tend not to go to court because they're being proactive. It's the negligent and the ones that are doing something evil that usually get sued. Now, there are outliers to everything, but you have to think about, are we going to let the outliers determine what good work we do, or we're going to keep on working with the larger groups? It's a very good chance that you're already collecting data that's actionable that you're not acting on. So that's in the studies that show that, right, in the clinical data. So I think that ship already sailed also. So it would be better for us to look at what can we do with our data to have early interventions, because if we can identify issues when they're very small, we're more into the prevention space and early intervention. That way, if something does go wrong and we didn't catch something in the data, it was really in a low risk area, not in a very high risk area. So I think we will always need clinical judgment. And what we're doing with these algorithms is we're installing clinical judgment, the protocols that we would get in textbooks and with clinicians into more of a sustainable and arguably more consistent algorithm than clinicians, because clinicians vary quite a lot in our assessment and treatment with the data we get.
Hi, this is Deb LC from Minneapolis, Minnesota, and I have a two-part question. First of all, thank you both, Jay and Michael. This was awesome to be able to kind of go through this from both perspectives. But in looking at all of the AI that's out there, could you comment on, either one of you or both, on the change in the false positives and the false negatives and what you're benchmarking that to? Because I think from a clinician's perspective as a provider, and wanting to trust things, as you so pointedly pointed out, that garbage in, garbage out. And have you seen those benchmarks change over the years as far as to determine what your false positives and your false negatives are?
Yeah, that's a really, really great point and a good question. And I don't know if I'll be able to give a completely satisfying answer, but I will say a couple of things. I mean, one is, I think we've learned a lot. We've got a much better tool bench to build these algorithms, number one. And so, we can routinely try 150 algorithms on the data to see what performs better. And so, yes, there is some, I think, material improvement in performance based on that. But what you're pointing out is really, really critically important for everyone to, I think, internalize that it's not just, there's decisions in the design of the algorithm about where, whether you favor sensitivity or specificity, for example, whether you want to, reduce false negatives. I'm sorry, sensitivity wise, you don't want false negatives. And from a, or from a noise standpoint and just being deluged with alarms, it's positive predictive value. But you actually make design decisions when you're building the algorithm of which to favor. And so it's very important to involve clinicians to ask the question of, would you rather have 7 false positives to get, those 3 true positives that you might not get otherwise? And then how you design that information into the workflow is the second piece. Sepsis is a great example because it's hard to do, right? Hard to build good algorithms for. But if you can catch, because by screening enough patients that you've caught some actual true positives, the impact on mortality is substantial. So those are clinical trade-offs, right? That need to be factored into algorithm design.
Yeah, and I would echo that. I think it's it's important to know it's different for every vendor and then every tool of every vendor. So there's not one AI out there. It's not like one bicycle that everybody shares. Everyone is very individual and unique. And so those are good questions to ask of that vendor, whichever one you're using. At the same time, I tend to use AI and think of it more as a screener just for places to check out and look. So I'm expecting false positives and hoping there's not false negatives. And I think of it as threads to pull in my process. So I pull the thread and the whole sweater falls apart. Then good thing I pulled it. I just want to know where are the threads to pull. It should make me more efficient as a clinician if I'm given more data that is good data. So there is this balance of which one. So you're bringing up a great question, and to Mike's point, I don't think we have a great answer right now, but it is individual to each product.
Guys, this is David Cattell-Gordon. Good morning. Thank you very much for a passionate and engaged discussion. It really is provocative, and I damn well believe we better be having this discussion a lot. And it's just been great. One of the things you said, Jay, that was really compelling for me is how this is a prevention, early intervention tool. whether we're looking at screening for diabetic disease, diabetic retinopathy, where we already use AI, whether it helps the radiologist do a breast mammography and get a great read. I wondered, we talked a lot about in the treatment realm, but I wonder your view in mental health especially, and you know my passion is about autism, the role that you believe AI has in early diagnosis so we can intervene early. We all agree that the earlier the intervention in most diseases, the better the outcome. What do you see that role as being?
I think that's one of the more promising areas right now in AI is predictive analysis and that screening tools. And we're both passionate about autism, especially, but that you can also extrapolate that to learning disorders, reading disorders, other types of, early identifiable items. So you think about the world's expert in diagnosing autism, if they can get them at 4 months old instead of 4 years old, what could you do with a child along the way? And I think that's the area we need to be working in more.
Thank you.
Hi, this is Victoria Moy again. I have a question about on bringing people on board, clinicians, convincing clinicians to use, decision support. I've been talking to various people about using simulation techniques. For example, like a pilot would use a simulator. What do you both think of that idea, and are there better ways to, get clinicians on board?
Yeah, and I'd love to hear Michael's view on this too. I think we should be working on those tools for the mental health clinical education space. There's the difficulty is the ones that make these programs are usually the counseling, psychology, social work. We're not making clinical tools digital ones at least very, very well. The majority of clinical education is a PowerPoint voiceover. I think we could simulate client interactions, and I use little video clips to simulate, what a crisis looks like, or a psychosis looks like, a psychotic episode. So I think we could be using and creating simulations, maybe even like avatar-like, or and AI, so that the representation of the AI human was very low tech. There are some that look amazing, like a real human being. And so I think we could really simulate, and then imagine a live clinical supervised session with an avatar instead of a student intern with trying it on a real person. That's kind of archaic compared to what if we could do this in simulation, where somebody else could be the avatar, another clinician could be the avatar, helping the person, the clinician student face real time what it's really like to work with people, and then coach them in real time on how to do that better. So I think we have a lot of good work we can do there as well. So I'm glad you're thinking about that.
And I'll give just a quick add-on to that. I think number 1, 2, and 3 is evidence. Evidence that it actually works. And I think clinicians are scientists at heart often, and so there's nothing that's a substitute for actual evidence that it works, and understanding the sensitivity, specificity, things of that nature. But I would also say there's a whole field of study in AI and machine learning, specifically around explainable AI. And there's some interesting techniques that are starting to emerge. I'll just mention a couple. Autoencoding is a technique to actually, use AI on AI to explain AI, if that makes any sense at all, by kind of reverse engineering some of the features, things like that. And another technique is adversarial machine learning, which is similar, but I do think there's also a wide range of techniques in machine learning, and some are easier to understand than others. Decision tree type algorithms and Bayesian algorithms are easier to understand. And so we often start with clinicians at the start of a research project to build algorithms and ask them how important it is that it be understandable for it to be used. And sometimes deep learning is just not a good candidate for that reason.
Excellent.
Thank you.
I am so sorry to be the one that has to break up this party. This has been awesome, but we've run up against a hard stop. So Dave, could you put up the final slide, please? And I'd like to remind everyone to, to provide session feedback for this session. And Jay and Michael, I think it's been incredible. Thank you so much. And thank you everyone for attending. Feel free to take a break, or you can visit the virtual exhibit hall, and there's also virtual Zumba coming up. So thanks everyone.